Working on standard 12 rigid body equilibrium. We have a mountain climber is rappelling down a vertical wall. Okay, the rope attaches to a buckle strapped to the climber's waist, 15 centimeters. Okay, to the right of his center of gravity. If the climber weighs 770 newtons, find A, the tension in the rope. And then we have to find B, the magnitude and direction of the contact force exerted by the wall and the climber's feet. Here's the drawing of the climber. It's kind of bad drawing, but it is what it is. Here's it's 25 degrees was given, okay, and the 91 centimeters and a 106 centimeters was given as well. Alright, we know that the climber weighs 770 newtons. So then here's my free body diagram. I take what I was given, 25, 65, 90 equals 180, so it's a 65 degree angle right here. Alright, Fy be the vertical wall. Here's the 91 centimeters and 106. We need to find, and then here's the sine of 65 that I'm going to use both of these, cosine and sine. We need to find the tension on A, and then we need to find the magnitude and direction on B. Alright, so using all this, I can figure A and B. A, we're going to start with the tension of the rope. We had the weight, the 91 centimeters equals the tension, of sine of 65, 106 centimeters. Get tension over by itself, 770 newtons times 91 centimeters divided by 106 centimeters, and the sine of 65 gives me T equals 729.37 newtons. Okay, now to find the magnitude and direction. Okay, so the Fx, we're going to use x and y. T cosine 65 for x, and we use it for the y, use sine of 65. So here is what we had before, the 729.37 newtons times the cosine of 65 gives me 308 newtons on x, and that'll be used later. The y, separate the y to one side, 770 newtons minus what we got before, 729.35 newtons. And I'm sorry, I must have messed up on this one. It should be a 37. I might have calculated it the right way, but here it is, the 7. Just call it that. Okay, 65. And I get 770 minus 661, and I have 109 newtons. Okay, so all I'll do is pull this down, multiply those, get 661, and I have 109. Find the magnitude and direction of what we just came up with. So now I put them in the square root on the F. Okay, 308 squared plus 108 to the second, and I get 303 newtons. Figure out theta. I hear is inverse of tangent you have to do for the direction. 109 newtons divided by 308 newtons, and you get 0.3539. Do the inverse of tangent, and you get 19.5, and that's magnitude and direction. So thank you for all your help.